I think part of the biggest problem is just how the problem is framed, okay? And that's one of the biggest things that makes probability challenging. Like I said, the number crunching is just addition and multiplication. That's all. The other 99% of solving the question is interpretation. So let's read it carefully. How many consecutive draws need to be made? So immediately, you're asking a fundamentally different question. You're not asking the question of what is the probability blah blah blah, which will give you a fraction of some kind, okay? You're asking how many, right? So it's going to be an integer of some kind, yeah? Obviously probability will be involved, but already we're trying to approach it from a different angle. How many consecutive draws need to be made for there to be greater than 98% chance that at least one jackpot prize will have been won? Okay, so there's the next challenge, right? That here's the probability of at least one jackpot being won, but I don't want a specific number. I have an inequality, right? Greater than 98%. Greater than 98%. Okay, so we've got two problems, right? The first problem is it's asking a different question entirely. The second problem is it's not an equality at all. It's an inequality. So how do I even go about this? Right? Let's consider this guy. Probability of at least one jackpot. Okay. Now, how can I start to work with this? Well, there's lots of different ways, just like in this scenario, there's lots of different ways that this can happen. Okay. For instance, I could win on the first draw. That'd be nice, right? What would be the probability of winning on the first draw? 1/60. Good. But clearly, there are more ways to win than that. I might win next time, okay? Now, here's the important thing. Number one, it's not simultaneous. This is a separate event now, so I'm adding, okay? But for the next time, right, what that implies is I didn't win the first time, right? Now I'm going to win on the second try, right? So therefore, if I didn't win it here, then I lost the first time, and then I won the second time, right? That's a way to get at least one jackpot, right? There's another alternative. Okay. Suppose I don't win the first time, don't win the second time, I could win the third time, right? Times. Okay, now, what is this thing? What is this? I mean, obviously this goes on forever, right? But this looks to me like it's a GP, isn't it? Right? Just to make it more obvious, you take out your common factor, 1/60, right? And then you're getting 1 plus 59/60 plus 59/60 squared, and so on. Okay? Now, it actually has to end somewhere, doesn't it? Because you're not going to sit there doing jackpots forever. The last one would be, I guess, if you drew it n times. If you had n draws, what would the last number be? This is the first draw. This is the second draw. Second draw. That's the third draw. The nth draw must be 59/60 n minus 1. Okay? Now that's the thing you want to be greater than 98%. Okay? So you can fold that into a GP. You can take the sum and you can solve for n from there. But I don't like that way of doing it. My brain hurts even looking at it, right? And it's long. It's very time consuming, right? Is there a better way? Or maybe I should say, how do I get to a better way than this? Okay. Well, like I said, it's all about language, right? See this? See this? It's sneaky. They deliberately worded it like this to obscure it and to make it hard to work for it. This is a complement of something, right? Or I could say the complement of this is something else that is much, much easier to work out, okay? What's the only way for you not to win at least once? And the answer is you have to win 0 times. You just got to keep losing, right? So now reverse the game, okay? If you reverse the game, you say, okay, what's the probability of me never ever winning, right? Okay, so probability of never winning. Okay, never winning. Now how do you work out this thing, right? Instead of 1/60, right? Instead of 1/60, you want to get 59/60, right? And then what do you do to this thing? Remember, I never win. Never, ever, 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 ever. Okay. So for instance, if I drew it, let's go back to this. If I drew it 4 times, right? How many times do I have to do this to never win? And the answer is all 4 times. Right? All 4 times. If I did it 40 times, I need to do this all 40 times, right? If I did it n times, right, n draws, I'd have to lose n times, okay? This is much easier to work with than this sort of disaster in here, okay? Now, because this is the opposite of this is the complement, right? I don't want this to be 98%. I want this to be 2%, right? Or I almost want it to be 2%. Remember we said at the beginning, the first problem is it's about how many. The second thing is that it's an inequality, right? So I should have an inequality in here. Which way should it go? I want the probability of never winning, which is this. I want it to be less than 2%, right? Less than 2%. Does that make sense? I want this to be greater than 98%. That makes this less than 2%. Okay. Now, to solve this, to work out which way, like what value, I am going to go back to this equation, right? When you solve that, that'll give you the boundary point, and then you can decide which way to go. Okay. So when you look at this guy, let's make it a decimal to work with it a little easier. 59 over 60 equals 0.02. Sorry, there's an n there. Okay. So I'm solving for n. So how do I rewrite this thing? I'll need to use a log, won't I? Okay, so it'll be log base what? The bases stay the same. The base here becomes the base here, right? So 59 over 60, okay? I want it to eventually get to 0.02, 0.02. And n becomes the new subject, right? We know this with logs. So now, in order to evaluate this, in your calculator at least, you'll need to do change of base. Right, so I'll say n equals, how shall I do it? I try to sort of default to natural log, okay? So you've got that on the top, and this on the bottom, okay? And your calculator will make mincemeat of that, right? Now, you get a decimal out of this, because all these numbers are all icky, right? I think you get, what, 232 point, someone got it there? 7, 5, blah, 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 doesn't matter, okay? Now you have a decision to make. Do I have to go up or do I go down? Do I go up or do I go down? Okay. Now you've got 2 alternatives here. You can think about it logically, or under exam pressure, you're like, my logic sort of center's just fried, okay? You can just try it. You can just try it because there are only 2 options from here, right? It's either going to be round down, right, or round up. Okay. Now your intuition will probably tell you it's one or the other, but I'm just considering, you're in an exam, you don't want to risk it, just try it. It's very easy to try, okay? Here's my n right in here, right? So one of my alternatives is 59 over 60 to the power of 232, right? I can work that out. That'll give me a decimal of some kind. What will it be? 0.0 what? 23, was it? 20? 20 what? 2025. Okay, now, what did I want? I wanted the probability to be less than 2%, but I am over 2%, right? I'm over 2%. I'm not there yet. I'm not underneath that threshold. I haven't limboed underneath yet. So, I've got to go one more. If you do it, if you multiply by 59 over 60 one more time, you should just sneak under, right? What do you get? 0.0199, blah, blah, blah. There you go. We just snuck underneath, okay? Which means, obviously, the complement of this will be greater than 98%. It will be 98.01%. You get the idea, okay? So you can see that even though it's so simple, you're like, the complement, not heads, not tails, that's basic stuff. Well, can you identify it? Right? Can you identify it? That's what it's all about. And then it makes problems just sort of fall out really easily, right? If you can pick them out.